this lecture number 4 of trigonometry, and welcome to my channel Study with me. Here in this lecture we are going to study sums related to trigonometric identities. So jumping to the first slide. So the question is, if sine theta is equal to 20 by 29, then find cos theta. Solution will be in method number 1 we are going to solve with identities, trigonometric identity. Here we know that for sine theta we know the formula, that sine square theta plus cos square theta, that will be equal to 1. Square theta will be equal to 1 minus sine square theta. As this sine square theta is jumping here, it will change its sign from plus to minus. So cos square theta will be equal to 1 minus bracket 20 by 29 bracket square. So cos square theta will be equal to 1 minus bracket 400 divided by 841 bracket complete. Cos square theta will be equal to 841 minus 400 divided by 841. So here 400 divided by 841, this 841 is getting cross multiplied by 1, and we'll be getting 841 minus 400 divided by 841. So now we'll be getting cos square theta, that will be equal to 441 divided by 841. Now taking the square root, we'll be getting cos theta is equal to 21 by 29. Here 441 square root is 21 and 841 square root is 29. Now we are going to the next slide. In this next slide we are going to see alternate method for the same question. If sine theta is equal to 20 by 29, then find the value of cos. Here in this method we have to consider a triangle. Let us name it as ABC, and we are naming this base of triangle as x, and this height will be equal to 20k, and this AC will be equal to 29k, and the angle between them is theta. Here we know the formula of sine, that is sine theta is equal to opposite upon hypotenuse. As we know the sine theta is equal to 20 upon 29, the ratio will be getting divided as 20k to that of 29k. The k term will be constant, and the x bc we have to calculate. So sine theta will be equal to 20 by 29. From the figure we know that the sine theta is equal to AB by AC. See here, AB by AC. This is the opposite side and this is hypotenuse. Let BC is equal to x, this BC side. According to Pythagoras theorem, AB square plus BC square is equal to AC square. Therefore 20k bracket square plus x square, that will be equal to 29k bracket square. So we will be getting 400k square plus x square, that will be equal to 841k square. So x square will be equal to 841k square minus 400k square. Here k square is common, so we can take this common out, and we can subtract 841 from we can subtract 400 from 841. So now x square will be equal to 441k square. So by taking square root on both sides, we'll be getting x is equal to 21k. So cos theta is equal to BC by AC. See, this is the adjacent side and this is the hypotenuse side, nearest side to the theta. So this will be the value of adjacent side, that is x, and we have calculated here x is equal to 21k. So we'll be substituting here, and we'll be getting 21k divided by 29k, that will be equal to 21 by 29. So cos theta will be equal to 21 upon 29. Now moving to the next slide. So here there is a new sum. If sec theta is equal to 25 by 7, then find the value of tan theta. So solution, method 1. We know that the value related to sine, the formula related to tan and sec, that is 1 plus tan square theta is equal to sec square theta. So we'll be getting tan square theta is equal to sec square theta minus 1. So here tan square theta will be equal to sec square theta minus 1. So tan square theta will be equal to 25 by 7 bracket square minus 1. Here we know the value of sec theta, here we have substituted it. So tan square theta will be equal to 625 by 49 minus 1. This 25 square will be 625 and 7 square will be 49. So tan square theta will be equal to 625 minus 49 divided by 49. As this 49 here gets cross multiplied by 1 and we will be getting this value. Tan square theta is equal to 625 minus 49 divided by 49. So tan square theta will be equal to 576 divided by 49. Hence we will be getting tan theta is equal to 24 by 7. As we know that square of 24 is 576 and square of 7 is 49. So moving ahead, we know that alternate method by using triangle. So we have done here same. If sec theta is equal to 25 by 7, then find the value of tan theta. This is the previous sum, but with the alternate method using triangle method. So solution will be there. Let us consider that sec theta is equal to PR by PQ. This PR by PQ. We know that the sec theta is equal to hypotenuse upon adjacent side. Here hypotenuse is 25k and adjacent side is 7k. So we have written here same PQ is equal to 7k and PR is equal to 25k. According to the Pythagoras theorem, PQ square plus QR square is equal to PR square. So substituting the values, we are knowing that 7k bracket square plus QR square is equal to 25k bracket square, and we'll be getting QR square is equal to 625k square minus 49k square. This 7k bracket square will be getting moving here and changing its sign from plus to minus. So we will be getting QR square is equal to 576k square and QR is equal to 24k. I will be changing this here it is QR square, and by taking square root we will be getting QR is equal to 24k. Now tan theta is equal to QR by PQ and we'll be getting 24k by 7k, that will be equal to tan theta is equal to 24 by 7. Now moving to the next slide. This in this question we have given an equation 5 sine theta minus 12 cos theta is equal to 0. Then find the value of sec theta and cosec theta. So 5 sine writing this equation again, 5 sine theta is minus 12 cos theta is equal to 0. Now moving this 12 cos theta in the right side, we will be getting 5 sine theta is equal to 12 cos theta, and again here 12 into cos theta is there, so multiplication is there on the right hand side. So this cos theta will go and divide sin theta and we'll be getting tan theta, and this 5 is getting multiplied here by sin theta. So this 5 will be getting divided on the right hand side, so we'll be getting tan theta is equal to 12 by 5. So we know the formula that 1 plus tan square theta is equal to sec square theta. So we'll be getting sec square theta is equal to 1 plus tan square theta. Sec square theta will be again equal to 1 plus bracket 12 by 5 bracket square. We have calculated the value of tan theta. Simply we are going to square it. Now sec square theta is equal to 1 plus 144 divided by 25. So sec square theta will be equal to 25 plus 144 divided by 25. We have simply cross multiplied by 25. So here 25 is getting multiplied with 1 and we are adding with 144 and completely dividing by 25. So sec square theta will be equal to 169 divided by 25, and then sec theta will be equal to 13 by 5 by taking the square root of 169 by 25. So cos theta will be equal to 1 upon sec theta, as we are knowing that cos theta is equal to 1. So 1 divided by 1 will, the value will be there, and here this double divide sign I have given to know that this is completely divided by this sec 1, that will be sec theta value, that will be equal to 13 by 5, and cos theta will be equal to 5 by 13. See here, simple division property is there: a divided by b divided by c divided by d. When this condition appears, we will be getting the value that a divided by b into d divided by c. This last term will get multiplied with first term, and this second and third term will be getting multiplied. So we are getting same here: 13 is getting multiplied by this one, and 5 is getting multiplied by the first one. So moving to the next slide. So cos theta is equal to 5 by 13, and we know that the formula is sine square theta plus cos square theta is equal to 1. So sine square theta plus 5 by 13 bracket square, that will be equal to 1. So sine square theta is equal to 1 minus bracket 5 divided by 13 bracket square. Sine square theta will be equal to 1 minus 25 divided by 169. Again we are going to cross multiply by 169. So 169 will be multiplied and get divided by divide. So we'll be getting sine square theta is equal to 169 minus 25 divided by 169. So we'll be getting sine square theta is equal to 144 divided by 169. So value of sine theta will be equal to 12 by 13. This question, 1 minus cos square theta bracket cosec square theta is equal to 1. We have to prove this, that this LHS will be equal to RHS. So LHS we are considering 1 minus cos square theta bracket into cosec square theta, and RHS will be equal to 1. First trigonometric identity: sine square theta plus cos square theta is equal to 1. So sine square theta will be equal to 1 minus cosec square theta. Then we are getting in LHS, that is equal to sine square theta into cosec square theta. So in LHS, sine square theta into 1 upon sine 1 upon sine square theta. Here value of cosec square theta is 1 upon sine square theta. So we'll be getting LHS is equal to sine square theta divided by sine square theta, and the same, there are same terms, so they will getting cancelled out, and we'll be getting LHS is equal to 1. So LHS is equal to RHS. Hence the question is proved. Now in this next we have to prove sec theta under root 1 minus sine square theta is equal to 1. So again we know the formula that so we have considered here LHS is equal to sec theta into bracket under root of 1 minus sine square theta, and RHS is 1. So we know that sine square theta plus cos square theta is equal to 1. We have cos square theta is equal to 1 minus sine square theta. Hence LHS will be equal to sec theta into under root of cos square theta. So LHS will become sec theta into cos theta, and we know the from the cos reciprocal formulas, cos theta is equal to 1 upon sec theta. We'll be substituting the same value, and we'll be getting sec theta divided by sec theta. Now LHS will be equal to 1, as the same terms in numerator and denominator, they will be getting cancelled out. So LHS will be equal to RHS. So sine theta, sec theta under root 1 minus sine square theta will be equal to 1. Now turning to the next page, tan theta into sine theta plus cos theta is equal to sec theta. Now we have to prove this one. So solution will be, let us assume that LHS is equal to tan theta into sine theta plus cos theta, and RHS is sec theta. So in LHS we are converting this tan theta in sine theta and cos theta. So tan theta will be equal to sine theta upon cos theta. We know this formula, we have seen this formula in the first lecture, that tan theta is equal to sine theta upon cos theta. So LHS will be equal to sine theta upon cos theta into sine theta plus cos theta. Now we will be getting sine square theta, as this sine is getting multiplied here with sine. We will be getting sine square theta divided by cos theta plus cos theta. Here, by doing cross multiplication, this cos theta will be get multiplied by cos theta, and we'll be getting sine square theta in divided by cos theta plus cos square theta divided by cos theta. Now, as the denominator is same, we can take it common out. So sine square theta plus cos square theta divided by cos theta. Here we know the formula that sine square theta plus cos square theta is equal to 1. That is our trigonometric identity number 1. So we'll be getting LHS is equal to 1 upon cos theta, and 1 upon cos theta is equal to sec theta. So LHS is equal to RHS. Hence proved. Now turning to the next slide. 1 minus cos theta in one bracket into 1 plus cos theta another bracket into 1 plus cot square theta is equal to minus 1. So we'll be considering this whole part as LHS, and this 1 is equal to RHS. So now we know the formula of a minus b into a plus b, that will be equal to a square minus b square. Same we have done here. 1 minus cos theta into 1 plus cos theta will give us 1 minus cos square theta. So LHS will be equal to 1 minus cos square theta into 1 plus cot square theta. And we know that from the trigonometric identity number 1, sine square theta plus cos square theta is equal to 1. So we will be getting sine square theta is equal to 1 minus cos square theta. So substituting this value, we will be getting LHS is equal to sine square theta into 1 plus cot square theta. Now LHS will be equal to sine square theta plus sine square theta into cot square theta. So now LHS will become sine square theta plus sine square theta into cos square theta divided by sine square theta. So we'll be getting LHS is equal to sine square theta plus cos square theta, that will be equal to 1. So LHS will be equal to RHS. We have simply multiplied this sine square theta in this bracket, and we are getting this value. You can do it by different ways, that we know the formula of trigonometric identity number 3, 1 plus cot square theta is equal to cosec square theta. You can simply substitute the value of cosec, this as cosec square theta, and sine's reciprocal is cosec theta, so we'll be getting cancel out, and we'll be getting the value as 1 only. So now moving to the next slide. Cot theta plus tan theta is equal to sec theta into cosec theta. Here CSC theta is as equivalent to as cosec theta. So solution, we will be getting LHS is equal to cot theta plus tan theta, and RHS is equal to sec theta into cosec theta. Now in LHS, we are going to convert it simply into sine and cos terms. So cot theta, we know that the formula of cot theta is cos theta upon sine theta, and tan formula are sine theta upon cos theta. So by simply cross multiplying, we will be getting cos square theta divided by sine theta into cos theta plus sine square theta divided by sine theta into cos theta. This sine theta into cos theta, this term and this term are common, we will be taking it out. So we will be getting cos square theta plus sine square theta in one bracket divided by sine theta into cos theta. So we will be getting 1 upon sine theta into cos theta, as we know the formula of trigonometric identity number 1, sine square theta plus cos square theta is equal to 1. Now in LHS, that will be equal to 1 upon cos theta into 1 upon sine theta. We are separating this term. So 1 upon cos theta is sec theta, and 1 upon sine theta is cosec theta. So LHS is equal to RHS. Now turning to the next slide. Cos theta divided by 1 minus tan theta plus sine theta divided by 1 minus cot theta, that will be equal to sine theta plus cos theta. Now we'll be considering LHS as this big term and RHS this small term, sin theta plus cos theta. So now in LHS, cos theta divided by bracket curly bracket 1 minus sin theta upon cos theta. We are simply uh, converting this tan theta in sin theta and cos theta, and we will be converting cot theta into cos theta and sin theta terms. So cos theta in cos theta will be divided by 1 minus sin theta upon cos theta. This cos theta will be getting cross multiplied here, and as it is in denominator, it will be getting multiplied with this cos theta. Similarly here, sin theta divided by curly bracket, in curly bracket 1 minus cos theta upon sin theta. This sin theta will be getting multiplied by 1, and sin minus cos in one bracket divided by sin theta, and this sin theta will get multiplied in the numerator. So we'll be getting here cos square theta divided by cos theta minus sin theta plus sin square theta divided by sin theta minus cos theta. So we'll be taking this negative term out from here denominator as to convert this similar to this first denominator. So this cos theta minus sin theta and cos theta minus sin theta will be taking it out, and we'll be getting cos square theta minus sin square theta divided by cos theta minus sin theta. As we know the formula of a plus a square minus b square, that will be equal to a plus b into a minus b. Similarly here, value of a is cos theta and value of b is sin theta. So cos theta plus sin theta in one bracket, in another bracket cos theta minus sin theta divided by cos theta minus sin theta. Now in numerator and denominator same terms are coming, cos theta minus sin theta, they will be getting cancelled out. So we'll be getting lastly cos theta plus sin theta, that is LHS is equal to RHS. Now moving to the next slide, we have another question. Tan 4 theta plus tan square theta is equal to sec 4 theta minus sec square theta. Now solution will be there. We'll be considering LHS as tan 4 theta plus tan square theta and RHS as sec 4 theta minus sec square theta. Now in LHS, tan 4 theta plus tan square theta is there. We'll be taking tan square theta term out, common out. So we'll be getting tan square theta into tan square theta plus 1. We know the formula that tan square theta is equal to sec square theta minus 1, and tan square theta plus 1 is equal to sec square theta. It is the second trigonometric identity. The trigonometric identities are very important to solve this type of questions, so please study for this trigonometric identities. Then we'll be getting from LHS, that will be equal to sec square theta minus 1 into sec square theta. Here 1 plus tan square theta's value is sec square theta, and tan square theta's value is sec square theta minus 1. So this multiplying sec square theta in this bracket will be getting sec 4 theta minus sec square theta, that will be equal to our RHS. Hence proved. Now turning to the next slide, under root of sec theta minus 1 divided by sec theta plus 1 will give us cosec theta minus cot theta. Now we'll be considering this as LHS and this term as RHS. And in this LHS, we are going to cross multiply. So we'll be getting under root of sec theta minus 1 into sec theta minus 1 divided by sec theta plus 1 into sec theta minus 1. So LHS is equal to under root of sec theta minus 1 bracket square divided by sec square theta minus 1, and we'll be getting LHS is equal to sec theta minus 1 bracket square divided by tan square theta. As we know from the trigonometric identity number 2, tan square theta is equal to sec square theta minus 1. So in LHS we will be getting sec theta minus 1 as this square term and this under root term will be getting cancelled out, and this square term and this under root term will be getting cancelled out. So we'll be getting sec theta minus 1 divided by tan theta. Now we'll be splitting this tan theta. We'll be getting sec theta divided by tan theta minus 1 divided by tan theta. And we know that sec theta's value is 1 upon cos theta and tan theta's value is sin theta upon cos theta. Now this cos theta and cos theta will be getting cancelled out, and we will be getting 1 upon sin theta, and for 1 upon tan theta the value is cot theta, so we'll be getting cot theta. So finally 1 upon sin theta is reciprocal of 1 upon sin theta's value is cosec theta, so cosec theta minus cot theta will be getting here. Now this is equal to RHS, hence proved LHS is equal to RHS. Now turning to the next slide. Now in this sum, 1 minus sin A divided by 1 plus sin A is equal to sec A minus tan A bracket square. Here in the place of theta, any alphabet, any symbol can be coming. Here theta is replaced with A. Now in LHS will be this term, and RHS will be this sec theta sec A minus tan A bracket square. So LHS will be there is equal to 1 minus sin A divided by 1 plus sin A. After cross multiplication we'll be getting 1 minus sin A bracket square divided by 1 minus sin A into 1 plus sin A. Now 1 minus sin A bracket square divided by 1 minus sin square A. Here we have cross multiplied means divide and multiplied by sin 1 minus sin A. So here the term square is coming, 1 minus sin A bracket square, and here we are after multiplying this sin A minus B and A plus B, here 1 minus sin square A will be getting. So now 1 minus sin A bracket square divided by cos square A. Here 1 minus sin square A is equal to cos square A. Further 1 minus sin A bracket square divided by cos A and bracket square. Now taking this square term outside of the bracket, and we will be getting 1 minus sin A divided by cos A bracket square. So dividing separately by 1 and dividing separately by sin by cos of A. So 1 upon cos of A minus sin A divided by cos of A and bracket square. So we'll be getting sec A minus tan A bracket square. As we know, 1 upon cos A is equal to sec A and sin A upon cos A is equal to tan A. So LHS is equal to RHS, hence proved. Now turning to the next question. Tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1 is equal to 1 plus sin theta divided by cos theta. Now the solution will be, let us assume that LHS is equal to tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1, and RHS is equal to 1 plus sin theta divided by cos theta. LHS is equal to tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1. Now here we are going to substitute for this 1 as sec square theta minus tan square theta from the trigonometric identity number 2. So the equation will become tan theta plus sec theta minus, in another bracket, sec square theta minus tan square theta bracket complete divided by tan theta minus sec theta plus 1. This sec theta, sec square theta minus tan square theta is in the form of a square minus b square, so we will be getting converted into a plus b and a minus b. So sec theta plus 1, sec theta plus tan theta, and in another bracket sec theta minus tan theta. So this tan theta plus sec theta will be getting common, and we'll be taking it out, and we'll be getting tan theta plus sec theta in another bracket, this 1 minus sec theta plus tan theta. You can multiply this term, you will be getting this same term, tan theta plus sec theta minus sec square theta minus tan square theta, divided by now divided by tan theta minus sec theta plus 1. Now our LHS will be becoming tan theta plus sec theta, in another bracket tan theta minus sec theta plus 1, and divided by tan theta minus sec theta plus 1. Now this tan theta minus sec theta plus 1 is the common term from the numerator and denominator. So we'll be getting cancelling it, and we'll be getting LHS is equal to tan theta plus sec theta. Now we'll be converting tan theta and sec theta in sine and cos format. So we'll be getting LHS is equal to sine theta divided by cos theta plus 1 divided by cos theta. So LHS will be equal to sine theta plus 1 divided by cos theta. As the cos theta term is common in the denominator, we'll be taking it out. So 1 plus rearranging this sine theta plus 1 as 1 plus sine theta divided by cos theta. So that will be equal to our RHS. Moving to the next slide. This we are given with the equation 5 sec theta minus 12 cosec theta is equal to 0. Then find the value of sec theta, cos theta and sin theta. So now we know that 5 sec theta minus 12 cosec theta is equal to 0. We will be converting this into cos and sin format. So we'll be getting 5 upon cos theta minus 12 upon sin theta is equal to 0. So 5 upon cos theta is equal to 12 upon sin theta. Now this sin theta will is in divide, will go in this side and get multiplied, and this 5 in divide will move this side and get divide here. So we'll be getting sin theta upon cos theta is equal to 12 by 5. So tan theta is equal to 12 by 5. Now we know the formula that from the identity that 1 plus tan square theta is equal to sec square theta. So sec square theta is equal to 1 plus tan square theta. Now sec square theta is equal to 1 plus bracket in bracket 12 divided by 5 bracket complete square. Now sec square theta will be equal to 1 plus 144 divided by 25. Now this 25 term will be getting cross multiplied by 1. So we'll be getting sec square theta is equal to 25 plus 144 divided by 25. Now this sec square theta is equal to 169 divided by 25. Now this sec theta term will be equal to 13 divided by 5. Now we know that the formula of cos theta is equal to 1 upon sec theta. From the reciprocal identities, cos theta will be equal to 1 upon 1 divided completely divided by 13 divided by 5. So this reciprocal term will be 5 divided by 13. Now moving to the next slide. As cos theta is equal to 5 divided by 13, we know that sine square theta plus cos square theta is equal to 1. So sine square theta plus 5 divided by 13 bracket square will be equal to 1. So sine square theta is equal to 1 minus 5 divided by 13 bracket square. So sine square theta is equal to 1 minus 25 by 169, and sine square theta is equal to 169 by 25, as 169 is getting cross multiplied by 1. So we'll be finally getting sine square theta is equal to 144 divided by 169, and the sine theta is equal to 12 by 13. Now in the next slide, if you want to calculate the cosec theta, then the cosec theta will be equal to 1 upon sine theta, and cosec theta is equal to 1 completely divided by 12 by 13. That will be giving us 13 divided by 12. So cosec theta is equal to 13 divided by 12. So moving to the next slide. Thank you everyone for watching this video, and please subscribe to our channel Study with me, and like the video. And if you have any doubt related to this trigonometry sums, then you can comment me. नीचे डिस्क्रिप्शन में आपको इस लेक्चर के नोट्स मिल जाएंगे, तो चेक कर लें.